Good afternoon to one and all. Today I am going to discuss about binomial theorem. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. So today's topic is binomial theorem. What is the statement of binomial theorem? How to prove binomial theorem? And we'll discuss some examples in the binomial theorem expansion as well as how to find the terms in the binomial theorem expansion. So first of all, let us discuss about the introduction of binomial theorem. It is the fundamental principle in algebra that describes the algebraic expansion powers of binomial. So in the case of any expansion consisting of only two terms, x plus y whole power n. Here in this expansion, there are two terms, one is x, another one is y. Any expansion consisting of only two terms, then it is called as a binomial. So according to the theorem, the expression a plus b whole power n, where a and b are any two numbers. We are going to consider any numbers. N is a non-negative integer. That means power of n is a positive number. Positive number. And we have to expand these terms from the 0th term to nth term. So in the case of suppose there is only two terms, we can easily find out with the help of the Pascal triangle. So Pascal triangle, the first term is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So if there is four terms, we can easily find out what is the first term, what is second term, what is third term, what is fourth term. Suppose if it is so length of the Pascal triangles will be extended, then it is difficult to find what is the corresponding value of the 58th term. It is very difficult. With the help of binomial theorem, we can find the value in the expansion. That is the advantage of binomial theorem. Why the name called binomial means it consisting of only two terms in the expansion. That's why it is called as a binomial theorem. Now consider the statement. So this binomial theorem can be proved with the help of the mathematical induction. So in the case of mathematical induction, we have to start with k equal to 1 is true. If k equal to 1 is true, then the same statement will be true for n plus 1. So if k equal to 1 is true, n plus 1 is also true, then automatically the statement, the theorem can be proved. So example, consider the binomial theorem can state that x plus y whole to the power of n. So the binomial theorem consisting of only two terms in the expansion, x and y, and it consisting of powers of n. So it is expanded as nc naught x to the power of n, y power 0. Then nc1 x to the power of n minus 1, y to the power of 1, and c2 x to the power of n minus 2, y to the power of 2. So when you are going to increasing, x powers will be decremented, y powers will be incremental. Y powers will be incremental. How to prove that? So we need to consider this one, a plus b whole power n. nc not a power n, y power 0 value is 1 only. So we are not going to consider the b power 0. Then nc1 a to the power of n minus 1 into b, nc2 a power n minus 2 b square, and so on. ncn a power a into b power n minus 1, ncn b power n is true for every positive integer. So we need to prove that it is true for all positive integers. That is the proof we have to prove in the case of binomial theorem. First of all, consider n equal to 1. So in the place of n, we have to substitute 1. So a plus b whole power 1. That means in the place of n, you have to substitute 1. 1 c naught. In the place of 1, n we have to substitute 1. 1 c naught, a power n value is 1. A power 1 plus in the place of n, again 1 is substituted. 1 c 1, b power 1. So that is equal to a plus b. A plus b whole power 1 is equal to a plus b. So n equal to 1 is proved. Then so same statement we have to prove for k terms. So what is the formula? So a plus b whole power k. Whole power k. So k c not a power k, because so b power 0 value is b only. So no need to consider, that is 1 only. K c not a power k. Next, in the place of n, you have to substitute k c1 a power k minus 1 b. Then k c2 a power k minus 2 into b square. and so on, kck, b power k, a power that is automatically 1, no need to consider. Now we need to prove that this is the k terms. Now we need to prove for p of k plus 1 is also true. We need to prove that p of k plus 1. How to get a plus b whole power k plus 1? That is, in the place of k, we have to substitute k plus 1. So here k is there, k plus 1, c naught, a power k plus 1. That is the first term. In the place of k, again k plus 1, c1, a to the power of k minus 1 plus k plus 1. Okay, automatically, so in the case of second term, we have to substitute k plus 1, then c1, a to the power of k minus 1. Again, so plus 1 you are going to substitute automatically, so it will be get cancelled. In the place of k, you have to substitute k plus 1 minus 1. 1 get cancelled, we are going to get k only, a to the power of k, b. Next, k plus 1, c2, then a to the power of, in the place of k, you have to substitute k plus 1 minus 2. You'll get k minus 1. The third term is k minus 1, b square, and so on, k plus 1, c, k plus 1, b to the power of k plus 1 is true. We need to prove this value. So first of all, consider LHS, left hand side. A plus b whole to the power of k plus 1. That can be divided into two parts. That is, a plus b whole power k and a plus b. That means we need to prove that it is true for n equal to 1, it is true. Then n equal to k is also true. Then we need to take k plus 1 is also proved as a true. Then automatically binomial theorem can be proved as a true. Take LHS, we know that what is a plus b written as it is. A plus b to the power of k is already present in the equation number 1. Substitute the same equation, kc naught a power k, kc1 a power k minus 1 into b, kc2 a power k minus 2 b square, and so on, kck minus 1 ab to the power of k minus 1, kck into b to the power of k. Take LHS and take what is a plus b, that is kc naught a power 1, a power k plus 1, a to the power of k plus 1. So we have to substitute, we have to multiply each value of a for the terms of kc terms. So kc naught a power 1, a power k plus 1, we are going to get a power k plus 1. Next, kc1 a to the power of 1, then plus 1. When automatically minus 1 plus 1 get cancelled, kc1 a to the power of k into b. kc2 here a to the power of 1 plus 1 will get minus 1. kc2 a to the power of k minus 2 into b square, and so on, kck a minus 1, then a to the power of 1. So already 1 is there, a into 1, a to the power of 1, a to the power of 1, we are going to get a square, b to the power of k minus 1 plus kck a to the power of a into b to the power of k. Then again it will be extended for kc naught, okay, that is equal to kc naught a to the power of k into b, okay, a to naught into the b. Next, after that kc1 a to the power of k minus 1 plus b square, then kc2 a to the power of k minus 2 b cube, and so on up to k plus 1 terms, up to k plus 1 terms. So the first part for a, the second part for b, So that is the kc naught a to the power of k into b, that is the first term. kc1 a to the power of k minus 1, so b power 1, b power 1, that is a b square. Then kc2 a to the power of k minus 2 into, already b square is there, b is to be multiplied, will get b cube. The third term is b cube. Next, kck minus 1 a into a to the power of k minus b to the power of k minus 1 plus b, that means plus 1. So automatically plus 1 minus 1 get cancelled, we are going to get b to the power of k. Next, fourth term is kck b to the power of k, already 1 is there, b to the power of k plus 1. These are the terms after multiplying each term of a with the entire term of k, a plus b whole to the power of k. After that, again we need to multiply b term with each term in the kth term, we are going to get this equation. Now we need to expand further. kc naught a to the power of k plus 1. Again, in the case of a to the power of k is common, a to the power of k into b is common, take it as out, then kc1 plus a to the power of k, then kc naught, okay, kc naught Then after that a to the power of k into b. What are the remaining terms? So that is a to the power of k into b. Again kc2 plus kc1. A to the power of k minus 1 into b square is take it as common. Then kc2 plus kc1 a to the power of k minus 1 b square. Like that we need to expand all the terms. So we know that k plus 1 c naught equal to 1 is equal to 1. kcr plus kcr minus 1 is equal to k plus 1 cr. kck is equal to 1. K plus 1 ck is also equal to 1. Substitute all those values. Then we are going to get the remaining terms. After expanding the remaining terms, we are going to get kc naught is 1. So kc naught to k plus 1 c naught is 1. Then we are going to get the remaining terms in the expansion is k plus 1 c naught a to the power of k plus 1. K plus 1 c1 a to the power, because we have to substitute all these values in this second equation. The remaining terms in the expansion are these one. So that is a plus b whole to the power of k. We are going to get so RHS as a plus b whole to the power of k. So LHS is a plus b whole to the power of k plus 1. But based on that, we have to prove that the terms in the expansion are this one. So it is a true. It is true because LHS is equal to RHS, then automatically binomial theorem can be proved. Next, consider the examples. Expand 2 plus x plus 3y whole to the power of 5 using binomial theorem. So we have to substitute those terms in the binomial expansion. What is the formula in the binomial expansion? X plus a whole to the power of n equal to nc naught x to the power of n a to the power of 0. Then nc1 x to the power of n minus 1 into a to the power of 1. nc2 x to the power of n minus 2 into a power 2. ncr x to the power of n minus r into a to the power of 1 and so on. ncn minus 1 x to the power of 1 a to the power of n minus 1. ncn x to the power of 0 into a to the power of n. This is the formula. Now we need to expanding these two terms in the binomial expansion. 2x plus 3y whole power 5. Here x is 2x, x is 2x and a is 3y and n is equal to 5. n equal to 5, x is equal to 2x, then a is equal to 3y. So we have to expanding those terms in the expansion of binomial theorem. In the place of n, you have to substitute 5 because n equal to 5. 5 c naught x to the power of n. What is x? 2x whole to the power of 5. What is a power 0? A power 0 is 1. No need to substitute as the value. Next, nc1 means 5c1 2x to the power of 4. That is a nc1. So n value is 5. 5 minus 1 means 2x to the power of 4. Next, a power 1, that means 3y whole to the power of 1. By default, it is 1 only. 5c2, 2x. In the place of x, you have to substitute 2x. 5 minus 2, that is 3. 3y whole square. Then 5c3, 2x whole square. That means that is the third term. 2x, that is this value will be decreased and this value should be increased. So x powers are decreased, y powers are increased, or y powers are that may be a powers, whatever it may be. 5c3, then 2x power square 3y, then 5c4, 2x to the power of 1, 3y whole to the power of 4. So how many terms we need to expand? That depends on the power of n. If it is a power is 5, 5 terms should be expanded in the expansion of binomial theorem. 5c5, 2x to the power of 0 means 1 only, 1 into 3, 5 whole to the power of 5. Next, so we know that 2 power 5 is 5c naught means according to the Pascal's triangle 1, 1, 1. So n equal to 0, n equal to 1, n equal to 2 means 1 to 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, then 1, 5, 10, 10, 5, 1. So that is n equal to 5. So 5c naught, this is the value of 5c naught, 5c1, 5c2, c3, 5c4, 5c5. 5c naught value is 1, 2 to the power of 5 is 32, 32 into x to the power of 5. Then 5c1 is 5, 2 to the power of 4 is 16 into x to the power of 5. then 3 to the power of 5. Then after that 5c2. So the value of 5c2 is 10. 2 1 ja, 2 2 ja, anyway we'll get 10. That is 2 power 3 is 8 x3, 9, 3 square means 9 y square. 5c3 value is also 10. So 3 3 get cancelled, 2 2 5 2 is 10. So that is a 10. Then after that the third one is 2 square means 4x square, 3 cube means 27 y cube. 5c4. 5c4 is 5, 2x is 1, 3 power 4 means 81 y to the power of 4. Next 5c5. 5c5 value is 1, 3 to the power of 5 value is 243 into y to the power of 5. So these are the terms in the expansion. X power 5 fifth term is 32, x power 4 term into y term is 240, then x cube into y square is 720, then x square y cube is 1080, then x into y to the power of 4 is 810, then y to the power of 5 value is 243. So these are the 5 terms can be expanded in the case of binomial theorem. Now we need to find one more example, x plus y whole to the power of n. So that means x plus y whole to the power of 7. So n equal to 7. X is x only, y is y only. Then we need to substitute. So nc0. nc0 means 7c0. X means x only, x to the power of 7 plus 7c1 x to the power of n minus 1. That means 6y. In the place of y, y only. Next 7c2 x to the power of 5 y square. How many terms we need to expand? Up to 7 terms. Because the power is n, we need to expand up to 7 terms. 7c3 x to the power of 4 y cube plus 7c4 x to the power of 5 y square. 7c5 x to the power of 6 x to the power of 3 x square y cube y to the power of 5 plus 7c6 x to the power of that is the terms are in 7 6 5 4 3 2 1 x to the power of 1 y to the power of 6 plus 7c7 x to the power of 0 y to the power of 7. What are the terms in the expansion? We need to follow so according to the Pascal's triangle, we have to constructing the values of what is 7c0, what is 7c1. So we know that what is the Pascal's triangle, that is 1 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 5 1 10 10 5 1 1 6 15 20 15 6 1 1 7 15 plus 6 21 15 plus 30 35 again 35 21 7 1. So these are the terms. What is 7c0 means? The first term in the expansion is 1. 7 x to the power of 7. 7c0 is 1. So 1 into x to the power of 7, that is the x to the power of 7. First term is x to the power of 7. What about the second term? The second term is 7c1. 7c1 means 7. So 7 x to the power of 6 y. Next 7c2, that is 21 x to the power of 5 y square plus what is 7c3 is 35 x to the power of 4 y cube. Next 7c3, that is 7c0, 7c1, 7c2, 7c3. 7c4 is 35 x to the power of 5 y to the power of 4. Next, after that 21 x to the power of 6 y to the power of 5. Next, after that 7c6 is 7. 7x y to the power of 6. 7c7 value is 1, that is x power 0 is 1 only. 1 into y to the power of 7 is y to the power of 7. These are the terms which are present in the expansion. These are the terms which are present in the expansion. Next, how to find the general term. Suppose it is a middle term or second term, third term. So if it is the only two terms, we can easily find out what is the first term, what is second term with the help of expansion. So if it is a term, that is also possible. If there are 100 terms are present in the expansion, how to find the value? So we need to follow the generalized formula to find the general term in the binomial expansion. What is the formula? T of r plus 1 equal to NCR a to the power of n minus r into b to the power of r. That is the formula. So a terms are reduced, b terms are increased. A terms are reduced, b terms are increased. So we need to constructing the general term in the expansion. We need to find the coefficient of x to the power of 9 and y cube in the expansion of 2x minus 3y whole to the power of 12. So what is n? N is equal to 12. What is A? A is equal to 2x including sign. Sign is also important in the case of binomial theorem. And what is B? B is equal to minus 3y. We don't know what is R value. Based on the expansion or coefficient in the expansion, we need to find out the R value. So 2x minus 3y whole to the power of 12, sigma R equal to 0 to n. That is nothing but 12. So what is the formula? 12 CR 2x. How to get 9? Suppose if you substitute 3 in the place of 9, so in the place of a to the power of n minus r. So to get x term as 9, we have to substitute r is equal to 10. That is x to the power of 12 minus 3. So that is x to the power of 9. To get x to the power of 9, so what is the r value we need to substitute? That we need to decide based on the coefficient. Here the coefficient is x to the power of 9. To get x to the power of 9, we have to substitute r is equal to 3. Then y to the power of r. That means in the place of b, so that is a 3y is there. That is a minus 3y whole to the power of 3. So what is the formula? 12CR. We know that R value. R is equal to 3. So 12CR. That means 12C3 into 2 power 3. That means we are going to get, so 12 minus 9. That is 12 minus 3. That is 2 power 9. Here there is a mistake. 2 power 9. X to the power of 9. Okay, that is a, so what is the remainder? 12 minus 3 means 9. 2 to the power of 9 into x to the power of 9 minus y whole to the power of 3 means 3 cube into y cube. So what is the value of 12C3 means 12 factorial by 12 minus 3 means 9 factorial into 3 factorial. After multiplying with 2 power 9 and minus 3 power, that means we are going to get, so 2 power 9 value. That means 2 power 5 is 32, then 2 power 6 is 64, 128, 256, 512. So 512 is multiplied with 12C3 and it is also multiplied with minus 27. We are going to get the coefficient value of x to the power of 9, y power 3 equal to minus, so 47,520 is the coefficient value of x to the power of 9 and y to the power of 3. Next example, find the coefficient of x to the power of 9, y power 3 in the expansion of x plus 2y whole to the power of 12. So now we know the we need to find out the coefficient value. TR plus 1 equal to NCR x to the power of n minus r into y to the power of r. So what is the x term? X is equal to x only. Y equal to 2y. R is equal to, we don't know what is R value. N is equal to 12. Now substitute, we need to decide the R value. We need to decide the R value based on the coefficient, that is x to the power of 9. 12CR. We don't know the value of R, right, as it is 12CR. What is x? X only. What is N? That is 12 minus R. What is Y? 2y whole to the power of R. So to get R value as 9, we need to substitute R is equal to 3. When R is equal to 3, we'll get x to the power of 9 and also y to the power of 3. That is 12CR. X value is x only. 12 minus 3, 2y whole to the power of 9. That is 12C3. X to the power of 9 into 2 power 9 into y to the power of 3. R value is 3. 2 cube into y to the power of 3. So what is 12C3 means 12 factorial by 12 minus 3 9 factorial into 3 factorial x to the power of 9 into what is the 2 power 3 value? 2 power 3 value is 8 into y power 3. That means 12 factorial into 9, 9 get cancelled, 12 into 11 into 10 divided by 3 into 2 into 8 into x to the power of 9 into y power 3. So 2 1 ja 2 5 ja. Then after that, so nothing will get cancelled. So 3 1 ja 3 4 ja. So after multiplying all these terms, we are going to get 1760 x to the power of 9 into y to the power of 3. So after cancellation, we are going to get the x to the power of 9 into y power 3 term is 1760 is the coefficient value of x to the power of 9 and y to the power of r. Next, find the coefficient of x to the power of 5 into y square in the expansion of 2x minus 3y whole to the power of 7. So what is the formula? TR plus 1 equal to NCR x to the power of n minus r into y to the power of r. This is the formula. So we don't know what is r value. Based on the coefficient, we need to decide which r value is suitable for the finding the coefficient in the expansion. So x is equal to 2x, y is equal to minus 3y, then n is equal to 7. We don't know what is r value. We need to find out r value. So substitute those values in the middle term of in the general term of the expansion. N is equal to 7. 7CR. X is 2x. N value is 7 minus r and y value is minus 3y whole to the power of r. Whole to the power of r. So to get x to the power of 5, we need to substitute r is equal to 2. If r is equal to 5, then we'll get x to the power is equal to 2. We'll get 7 minus 2 will get x to the power of 5 and also y square. So substitute r is equal to 2. 7C2 2 to the 2x whole power 7 minus 2 minus 3y whole power 2. Because r value equal to 2, then only we get the coefficient of x to the power of 5 and y square. So that is 7C2 2 to the power of 5 into x to the power of 5 minus 3y square y to the power of 2. Multiply 7C2 means 7 minus 7 factorial by 7 minus 2 means 5 factorial. 2 factorial into 2 to the power of 5 is 32 minus 3 square means we'll get positive term for the expansion of x to the power of 5 and y square. Now we need to calculate this value. 7 get cancelled. 7 into 6 divided by 2 into 32 into 9 into x to the power of 5 y square. So we'll get 2 1 ja 2 3 ja. So 21 into 32 into 9. So we need to multiply all the terms. We'll get 6048. 6048 x to the power of 5 and y square. After multiplying 7 into 3, 21. 21 into 9. 9 1 ja 9. 9 2 ja 18. 189 into 32. We'll get 6048 is the coefficient of x to the power of 5 and y square. Consider the next example. Find the coefficient of x cube and y square to the power of 7 in the expansion of x plus y whole power 10. So we don't know what is the value of r. So based on the coefficient, we need to decide. TR plus 1 equal to NCR x to the power of n minus r into y to the power of r. So that is x value is x only, x is x only, y is y only, n is equal to 10. What is the r value? We need to find out. So that is 10c or x to the power of 10 minus r into y to the power of r. So to get x to the power of 3, we'll substitute r is equal to 7. R equal to 7. So that means 10c7 into x to the power of 10 minus 3 means 10 minus this x cube into y to the power of 7. So 10c7 means 10 factorial by 10 minus 3, that is a 3 factorial, then 7 factorial, x cube into y to the power of 7. So what is 10 factorial by 7 factorial means 10 into 9 into 8 divided by 3 into 2 into x to the power of q, y to the power of 7. So 2 1 ja, 2 4 ja, then 3 1 ja, 3 3 ja, we'll get 120 x cube y to the power of 7. So 120 is the coefficient value of x to the power of 3 and y to the power of 7. So what we have discussed up to now, what is a binomial theorem, how to prove the binomial statement, and what are the examples for the expansion of binomial theorem, and finding the general terms in the expansion of binomial theorem. Thank you.